required: stopwatch, tall glass jar, scale, vernier calipers, glass beads, thread, glycerine. Procedure: measure the inner diameter of the glass jar using a vernier calipers. We can measure the diameter of the jar as 3 centimeters. So the radius of the jar is equal to 3 by 2, which is equal to 1.5 centimeters, which is equal to 0.015 meters. Now, fill the glass jar with glycerine. Take a glass bead of diameter 5 millimeters and drop it gently into the liquid. It falls down in the liquid with accelerated velocity for some time and then moves with a uniform terminal velocity. Using a thread, mark a reference point A below the point at which the bead acquires terminal velocity. Mark another point B below the point A using another thread so that the distance between A and B is 20 centimeters. Now, take another bead of diameter 5 millimeters and drop it gently into the liquid. A stopwatch is switched on when the bead crosses the point A and switched off when it leaves the point B. Note the time taken by the bead to travel the distance 20 centimeters. Then observed terminal velocity of the bead can be calculated using the equation V1 is equal to AB divided by T. That is, V1 is equal to 20 into 10 raised to minus 2 divided by 14.58, which is equal to 0.013713 meters per second. Record the observed and calculated values in a tabular column. The corrected terminal velocity of the bead can be calculated using the relation V is equal to V1 into 1 plus 2.4a divided by r. Here, the radius of the bead A is equal to 5 by 2, which is equal to 2.5 milliliters or 0.0025 meters, and the inner radius of the jar R is equal to 0.015 meters. Then the corrected terminal velocity can be calculated as V is equal to 0.0191982 meters per second. Record the value in the tabular column. Now, take another bead of diameter 7 millimeters and note the time taken to travel the distance 20 centimeters. Record the values in the tabular column. Repeat the experiment with beads of diameters 8 millimeters and 9 millimeters and record the values. Since the density of the liquid sigma is 1260 kilograms per meter cube and the density of the glass bead rho is 2600 kilograms per meter cube, the coefficient of viscosity of the liquid can be calculated in each case using the equation eta is equal to 2 by 9 into r squared g into rho minus sigma divided by v, and is found to be 0.9499 Newton second per meter square. We can now plot a graph with square of radius of beads along x-axis and terminal velocity along y-axis. The graph is a straight line. The coefficient of viscosity of the liquid can be calculated by using the slope of the graph in the relation eta is equal to 2 into rho minus sigma into g divided by 9 into slope, and is found to be 0.9499 Newton second per meter square. By calculation and from the graph, we can determine the coefficient of viscosity of glycerine as 0.9499 Newton second per meter square.